This week I recommend to read two papers very important to understand attention mechanism. The first one is this one, Neural Machine Translation by Jointly Learning to Align and Translate. This is published as a conference paper at iClear 2015. This is the first paper which used attention mechanism for machine translation. So essentially the idea is very simple. For encoder, use bidirectional RNN. So there are bidirectional structures. So two RNN structure we use. One is for forward pass and one is for reverse pass correlation. So there is some hidden vectors, hidden state vector for forward sequence pattern and the reverse sequence pattern. And let's say H is the concatenate vector for both direction. Okay, H2 as well. So each position compute its own hidden vector using bidirectional RNN. Okay, decoder use very simple attention mechanism. Basically, decoder also uses some RNN structure with attention mechanism. So RNN structure contains some hidden state vector Si. So each position I contain hidden state vector Si. And at each time, we compute Eij value to measure similarity between the current output position and the input position J, the current output position I and the input position J, which basically use three different parameter vector V, W, and large V. This is small v, and matrix W and matrix V. This is vector. This is matrix. All their model parameters. Vij compute this function, V transpose hypertangent W as I minus 1 plus V Hj. So here H is the hidden state vector of your encoder at position J, and Si minus 1 is the current hidden state vector, the previous time slot. And essentially the previous time slot's hidden state vector is kind of query information. And Hj is key information at position J. So using this query information and the key information, we can measure similarity between the position at I of your output and the value of J's input position. Okay, so Eij indicate the similarity between J's input position and I's output position. Okay. And using this Eij, you learn some softmax operations so that you can find out adaptive weight. So alpha ij is exponential Eij over summation exponential, let's say this is k, sum of k exponential Eik. Okay. So using this alpha ij, we can model the adaptive weight, and this control how much we focus on each position to generate the current positions output. And using this, we compute the cumulative information, kind of fully connected operations. So this is very simple attention mechanism where Hj is both key and value at j's input position. And using this Ci, you generate the output word, corresponding word, using some function f. Si minus 1, and the previous output yi minus 1, and the current cumulated information using the attention mechanism. It turns out that this simple attention mechanism outperforms all the previously existing algorithms, and it became very famous. Many machine translator adapt this idea and they improve performance much better than before. Okay. And Si also updated. And the output yi also calculated by this Si. Okay, so this is very simple attention mechanism. And using this idea, recently many papers and many NLP algorithm, natural language process algorithm, and many machine translator, essentially they use transformer structure. Transformer structure comes from this paper, Attention is All You Need. I strongly recommend to read this paper. This paper is published at URIPS 2017. Okay. So why this is Attention is All You Need? Why title is Attention is All You Need? Here, the authors do not use this bidirectional RNN structure to make embedding vector for your input and output. Instead, the paper just use attention mechanism all the time. Even for the encoder structure, they use attention mechanism. What is the meaning is, for the encoder, this is one computation block. Basically, for instance, for English input sentence, there are many words. Each word has 3 different vectors called key, value, and query. Each word has this triple vector set. And using the key and value and query, they compute some next layer hidden state vector called z1, z2 to zl if the length is l. Essentially, the operation is this. At each time, for each position, they use the query vector to understand the relation between any pair of words So each position use its own Corey vector and assess similarity between words using the Corey vector and the key vector. So because each input has both Corey and key, each input can compute inner product between Corey vector and key vector to understand similarity or importance of between this specific word and all the remaining words. And using this inner product, we essentially make adapted fully connected layer again. And here the weight computed using this Korean key inner product and softmax operation. So again, the weight values will be inside interval 0 and 1, and the sum of weight will be equal to 1. Okay, and this weight will be multiplied with this value vector to make this GI vector. Okay, this is very simple operations. Okay, and one another very important idea of transformer is basically we do not stop at here. We pass this GI vector using some neural network. So we manipulate this vector and to make some more sophisticated information. And we stack up this self-attention unit many times to generate more complicated structure and more abstract information. Okay, this is a very important idea of transformer network. And also, this single attention mechanism has many limitations. Actually, there are many different types of attention can be there. Right? There are many different views to understand one single sentence. So instead of using just one single key value query, they consider multiple head key value query structure. So essentially, each input contains several different key value query triple structure, and from this multi-head key value query, they generate many different point of view. And using this neural network, they combine this idea and make more nice information. Okay, this is very important idea of transformer network. Okay, so encoder just based on self-attention mechanism, and using self-attention mechanism, they adaptively combine different position information with different point of view, and using multiple layers and multiple self-attention unit, they can make a very nice encoded vector. So using many different self-attention units, in the end, they have many very nice key and value vector. And these key and value vectors go to, this is encoder for machine translator, go to decoder, of your machine translator to generate the output sentence words. Here, this key and value go to some layers of your decoder structure, and decoder structure also utilize self-attention unit. As I explained earlier, the self-attention unit consists of multi-head, query, key, value structure for each position, and this self-attention mechanism utilize inert product to assess the similarity or importance between two different positions, and then make some adaptively connected type of operations to combine all the informations. Again, the multi-layered structure, and here again we stack many different self-attention units so that we can have very nice information in the end. Okay, so the idea is very nice, right? The self-attention concept is very convincing, right? So many people have tried to use this idea to invent a new machine translator or some other natural language task, and they observe very nice properties and every state of the art on many natural language tasks. The self-attention idea and transformer structure dominate all the existing approach, and so the now readerboard, when you check the readerboard, all the algorithms consist of self-attention unit and transformer structure. Okay, to make a very nice performance, so the remaining thing is this: how to generate good query vectors, value vectors, and key vectors, so that from these queries, keys, and values, we can make a nice information. The queries and keys must have some meaning so that the inner product between queries and keys really tell us some kind of similarity or importance or something meaningful information should be there inside the inner product between queries and keys. So how to generate good queries, values, keys, that is really important question, and that is the most important part to have nice performance with your self-attention mechanism. So all the queries, values, and keys, of course, will be controlled by some learning process and some parameters inside your neural networks. So parameters of transformers, and some pre-trained word embedding vectors also very important to generate such good query values and keys. And many parts will make a very nice good queries and values and keys. But this is not easy task actually. Making good queries, good values, keys is not easy task. Essentially, we need a lot of data and huge computations. So when you read recent paper based on transformer structure and self-attention unit, you have to check the experiment setting, how they train the neural network, how much computation time they spend, and computing power they use to train the self-attention mechanism. Maybe you will be surprised. They use a lot. Okay. In the next week, I will explain some self-supervised learning and unsupervised learning. That is the key idea for GPT-2 and BERT. That is the state-of-the-art structure based on the transformer architecture, where I will revisit the importance of data size and the computing power to train such self-attention mechanism to have very nice performance.